My name is Anne Fischer, and as you said, I'm a PhD student at the Zhuoran School of Engineering, and I'm at the chair of materials handling, material flow, logistics from Professor Fottner. And yeah, I'm very happy to present you the paper called "Integrate Importance of Secondary Processes in Heavy Equipment Resource Scheduling Using Hybrid Simulation." So short outline, I just give you a small presentation of the motivation, then the research objective. Afterwards, I will present you the conceptual model, the case study to validate the model. And in the end, we will see the conclusion and the outlook. So what is the initial situation of the topic? Today, the construction industry has to deal with requirements such as increased time, cost, pressure, as well as increasing complexity. And to meet these challenges, the construction industry harness digital technologies, so the so-called construction 4.0 technology, and they network the machines or the equipment and materials, so all entities on the construction side, as you can see here in this picture. And parallel, in the last decades, the computer-aided simulation approaches are further developed. As already seen in this track, the usage of process simulation, the so-called discrete event simulation, is a proven tool for testing complex systems in advance and for validating variants with minimal efforts. And there exists also different levels of simulation approaches. And in a previous work, we divided it into a macro simulation and a micro simulation. And we combine these two approaches cyclically to first profit from the project scheduling of the macro simulation, and second, include the telematics data of the equipment on site to update the project schedule, as I said, cyclically. However, in order to give you a better understanding, you can see here a control loop, or to just give you an impression on the objective. So we have here the macro simulation based on boundary conditions and the dates, like in start date. Then we also have a micro simulation to evaluate the construction progress. And what is missing now, but I will present it in the next minutes, is the meso simulation to also study variance on the construction side. And in the end, we have something like a digital twin. So we have the execution on the construction side, and by adding or by using the telematics data of the equipment, we can push this back to the simulation to update the simulation on this, based on this data, and to vary different scenarios. And in the following, as I said, we will concentrate on the meso simulation, which will be the third part of our simulation approach. And this is the concept. So we have different phases in construction side. We in the first step, the user initializes the meso simulation model, creates different alternative scenarios, for example, by varying the number of equipment or different types of equipment. Then dynamically, it will be shared via SQL database and to the macro simulation to compute an optimum schedule. And during execution, we have the data is transferred to the micro simulation, and we can update the telematics data via the microsimulation, and calculate the construction progress. So the current state is then passed to the macro simulation, which calculates the optimal resource scheduling and its total duration. And based on the optimized schedule, the user has the opportunity to compute different modes via the meso simulation, which serve as the basis for decision making and the execution. So we have a very modularized simulation model. We choose a very modularized meso simulation model to capture different kinds of construction processes. Here we have, on the one hand, we have a standard window for elements for initialization, but also data import. Then we have different elements for the construction site specific ones to represent the process steps, but also the construction layout, like an equipment gate or the vehicles. And here you can see the simulation logic for it is hierarchically and also a bottom-up principle. And we start with the integration of the data, of course. Then we have different tasks, and the tasks are according to the bill of quantities. And when this job starts, it's I will go further. We have another kind of branch to get across the different types of or different activities of the single process. And here you have also the process which we focus on. This is the pile drilling production with the Kelly drilling rotary drilling rig, and this is the focus on this work. But not only this rotary drilling rig, but also the excavator. So we wanted to investigate on the importance of also on the secondary processes. So we did some different, or we did some alternative scenarios to compare these, and we compared their different. We focus only on the earth moving, or also on the earth moving equipment, which you can see here. We have the hydraulic excavator on tracks, on wheels, but also the wheel loader. And we can see that there is a significantly reduction when the demand is more than one equipment. We have also a weakened effect by continuing the increase if the demand, of course, is increasing, and the larger the capacity is, the more expensive the equipment will be. And in the end, we had an existing hybrid simulation model, which we extended towards a meso simulation. We have shown this, and we captured there the material flow on site in advance, and also the different process, sub-processes. This current meso simulation is, however, limited. For example, we didn't use a different kinds of probability distributions, or it's very hard to make the model if you have to model different kinds if you want to change the modes, and also it's not possible to make a parallel construction site project. So like if you have two rotary drilling rigs, for example. And an outlook is that we want to, of course, improve the model, but also extend it towards the resource, to analyze the resource sequencing. So I think I was a bit too long, but thank you very much for your attention, and I'm happy to answer your questions.